In today's lesson, we're going to learn how to multiply and divide rational expressions. So if the problem contains monomials only, you can multiply together and then simplify. Or you can do it backwards. You can actually simplify any coefficients, so reduce and then multiply together. If you have binomials or trinomials, you have to factor everything you can first, and then you need to simplify, which means you have to get rid of the common factors. So if you look at example number 9, we have monomials multiplied together. So we're going to, first way I'm going to show you is to multiply everything and then simplify afterwards. So when we multiply fractions, we multiply numerator with numerator and denominator with denominator. So we're going to multiply coefficients and variables. Just remember, when you multiply variables, you have to add exponents. So 6 times 10 is going to be 60. X squared times x to the power of 3 is going to be x to the power of 5, and y to the power of 7 if we add 3 and 4. And then we're going to multiply everything in the denominator. So 2 times 18 is going to be 36, x squared, and y to the power of 4. Now we're going to reduce the coefficients. So 60 and 36 are both reducible by 12. So if we reduce 60 by 12, we get 5 left. And if we reduce 36 by 12, we get 3. Which means I'm going to have 5 over 3. And then I'm going to subtract exponents. So 5 minus 2 is 3. And 7 minus 4 is also 3. And this is my simplified version of this complicated multiplication problem. In example number 10, I'm going to show you a slightly different way. I'm going to actually reduce first before I multiply. So I'm going to look at the coefficients, and when you have multiplication of fractions, you can reduce coefficients within the same fraction, so numerator with denominator, or you can reduce across. So if you look, the coefficients are 4, 15, 5, and 12. So I can reduce 4 and 12 together, and that will give me 1 and 3. And then I'm going to reduce 5 with 15, which will give me 1 and 3. And then I'm going to multiply kind of like smaller values. So in numerators, I have 1 times 1, which will be 1, a, and then I add exponents. So a to the power of 5 and b to the power of 8 over 3 times 3 is 9. A to the power of 1 times a to the power of 4 is going to be a to the power of 5, and b to the power of 10. Which means now I need to deal with variables. When I divide variables, I'm going to subtract exponents. A to the 5th divided by a to the 5th. 5 minus 5 is 0. Anything to 0 power is 1, so they cancel each other out. B to the power of 8 divided by b to the power of 10 will give me b to the power of negative 2, which now I have to rewrite as a positive exponent. So I need to take the reciprocal, and that will give me 1 over 9b to the positive 2. Okay, with division, to divide rational expressions, we are going to change this problem into multiplication problem, and we're going to multiply by the reciprocal. Which means you keep the first fraction without changing anything, and then you're going to multiply by the reciprocal of the second fraction. After that, you need to multiply across, or you can simplify and reduce coefficients before you do that. I prefer reducing because it's easier to multiply smaller numbers. So I can reduce 5 and 35. That's going to be 7 and 1. And then I can reduce 8 with 16, and that will give me 2. Now I'm going to multiply numerator with the numerator. So P, Q to the power of 6 over 2 times 7 is 14. P to the power of 3 times P to the power of 2 is P to the power of 5. And Q squared. After that, we are going to subtract exponents, which will give me, this is 1 over 14 if there is no number in numerator, which means it's 1, and then P to the power of 1 divided by P to the power of 5 is P to the power of negative 4, Q to the power of 4 if you subtract 6 and 2. So this term with the negative exponent has to be turned into positive, which means I'm going to have Q to the power of 4 over 14 P to the power of 4. Okay, in number 14, still we're going to change this division problem into a multiplication problem. So I'm going to keep the first fraction without changing anything, and I'm going to change division and take the reciprocal of the second fraction. After that, we're going to factor anything we can in both fractions. So the first fraction, if you look at the denominator, there's a greatest common factor of 4. So I'm going to factor out 4. And then if you look at the numerator of the second fraction, we have a trinomial that we need to factor. So we're looking for factors of negative 6 that are up to 1. And these factors, I'm going to write it here on the side, are going to be 3 and 2 with positive 3 and negative 2, which means I'm going to have x plus 3 and x minus 2 over, and there's a greatest common factor of 2x in the denominator. So you need to factor everything you can. After you factor everything, now you look for the common factors. And if you notice, we have x plus 3 in both numerator and denominator, so we can reduce them and cross them out and cancel them. And also, notice that you have x minus 2 in the first fraction denominator and x minus 2 in the numerator of the second fraction. So you can take them out as well. And then you're going to multiply what's left. So we have 10 in numerator, and then it's going to be 4 times 2x in denominators, which if we multiply together we get 10 over 8x, which can be reduced by 2, and that will give me 5 over 4x. I made a mistake, not 2. We're reducing by 2, so 4x. And this is the simplified version of this complicated problem. Okay, so the next two questions are open-ended questions for you to write in your own words the steps to multiply two rational expressions and to divide rational expressions, and then give example of each.